Hello. We come to section 2.7 today. We're talking about derivative and rate of change. So if we learn about calculus, we must learn about derivative and rate of change. Um, so what's the definition of of derivative? Keep in mind that um, if we let f be a function and a be a number in the domain of f, we define the derivative of f at a to be in the form as f derivative of a equal to the limit of fa plus h minus fa divided by h, with h go to 0, and if the limit exists. So that's the reason why we have learned about the limits, and now we use the the knowledge from the limit to apply in finding the derivative and the rate of change. Okay, so what does the derivative of f at a represent? So, so if you see at like P and Q over here, right? P here, Q here. If I'm asking you about the slope of secant line through P and Q, it's going to be equal to what? It's going to be equal to the change of, let me say the change in y divided by the change in x. So what is change in y? So the change in y is from here to here, right? You see that? Which is f of a plus h minus f of a. So I can rewrite it as f of a plus h minus f of a. Right. Okay, so let me also note here. This guy is f of a plus h, and this one is f of a. Okay, so you actually like take the a plus minus f of a, which is change in y. Now, in order to find the change in x, you just take the a plus h over here, minus for the a, right? A plus h minus for the a. So you can actually cancel a and minus a, and that's going to give you only the h. See that? All right, so all you can see is actually here, right? So okay, that is for the slope of the secant line go through P and Q. What about at point A? We have a red line here. We call the tangent line. Tangent line. T, right? And what we want to know about this is we want to know the slope of this tangent line. Okay, and And how can I find it, right? We actually gonna take the limit. Um, we're gonna take the derivative of f at a to get the slope of this tangent line. Okay, um, and we're gonna try to think about if the case that h go to approach to 0 and see, and if that's k, p and q go closer and closer to each other. So we're gonna say like take limit as h go to 0. Okay. So, yep. So then I have this formula also going to be the slope of the tangent line at the point A, f of A. And we also going to be the derivative of f and A. Okay. So now let's try to compute f derivative of A. Okay. The prime here is also called a derivative of A. Okay. So we're gonna try to find the derivative of f of 3 when f of x equals to x squared minus x. Keep in mind that we have the formula of the derivative is here. So what we want is we want to use f derivative of 3 equal to let me, maybe I have to go down. F derivative of 3, right, equal to the limit when h go to 0 of, remember that's a that become 3, right? I change all the a become 3. F of 3 plus h minus f of 3 divided by h. Okay, so we want to use the formula star over here with a equal to 3, right? Okay, so in order to take the limit of h equal to 0, for this whole expression, I need to have maybe a sidewalk. Say a sidewalk. I have f of 3. I want to know what is f of 3 going to be equal to, right? We know that fx is x squared minus x. So f of 3 you can just plug in 3 squared minus 3, which is 9 minus 3, and it's 6. Okay. What about f of 3 plus h? Okay. You can also just substitute 3 plus h instead of x, right? So remember that's now the inputs become 3 of h. Okay, so let me make the input become like a penalty first, right? And then I substitute that become 3 plus h, 3 plus h. See that? So so in order to do this one, I can do distribution of FOIL for the first term over here to get the like to expand it out and see what happened, right? So you also can using the special formula for the for a square binomial, which is 3 square, so equal to 3 square plus 2 times 3 times h plus h square, and then minus for 3 plus h plus 0 here. And I can simplify one more time. I have 9 plus 6h plus h square and minus 3. I do distribution out for the negative, so minus h. Okay, so now I have combined like term. I have h squared stay plus with 5h, and then minus plus with 6. That is for f of 3h. Okay. So time to substitute for this into so to back into the limit over here. So I have limits of f of 3 plus h, which is this guy, right? So h squared plus 5h plus 6. So okay, don't forget the parentheses because it's maybe affect with the subtraction later. So I just always keep this parentheses. Now I subtract for f3, which is 6. Okay, 6. And then I divide by h for h approach to 0. Now I'm gonna try to simplify by take away the parentheses. So I know that h squared stay plus 5h. Oh, I should also have the limit. How about that? So limits h squared plus 5h over h for h go to 0. For the 6, it's gone because 6 minus 6, right? Okay, so next step, what I do is remember that you cannot direct substitute h into this expression because why? Because if you plane, then the denominator becomes 0. So you want to eliminate the h at the bottom by factor 1h out on the top. So let me have limit of top now become factor of h times h plus 5 and divided by h for h go to 0. So now what you have is just gonna have h. You actually can cancel something, right? Cancel the limit the factor h. So now you should have only limits of h plus 5 for h go to 0. And you can substitute now, direct substitute now, which equal to 0 plus 5, and that's going to give you 5 as the answer. So this is f derivative of 3 equals to 5. So answer is here. Okay. And deal with that, it should be a number because why? This is a slope of the tangent as the tangent of a tangent line at point at x equal to 3. Okay, x equal to 3. So so this is I'm gonna say this is the slope of the tangent line at x equal to 3. Okay, of the fx equal to x squared minus x. Okay, so that's is let's move up and see what happened. So this is the graph of the of what we just did. The blue one here is the graph of the function f of x equal to x squared minus x. You see that it is a curve, and at point x equal to 3, right? You see that? We know that the y value also gonna be 6 from the graph. I don't even need to find it, but yeah, if you want to know it, at point x equal to 3 and y equals to 6, you can have a tangent. A tangent is a line that touch the graph on the one point. Okay, so tangent. Okay, T. It has slope. It has slope equal to 5. Tangent line T at x equal to 3. Okay. Okay. And y equal to 6. I can say that. Okay. So what really happening if you keep zooming on a curve closer and closer, right? Closer and closer. Eventually the curve looks just like a line. Okay, yes. Mathematically, we say the curve are locally linear. Yes, so if you look is like, if you zoom it closer and closer like this, right? You see at the point like 3x, 3,6 over there, it's like, it's like exactly like a line, right? So that's the reason why. But so after that, it's not going to be a linear. So let's use Desmos to graph the function y equals to x squared minus x, and its tangent line at 3,6. So you can use the function over here. I can show you. You can use Desmos with graph function y equal to x squared minus x, and then y equal to 5x minus 9. This is going to be the tangent line, right? At 3,6, and then try to zoom in. Okay, you can go ahead and try it first. I can show you that later in the class if you want. Okay, so let's move to exercise try here. Please go ahead and do exactly with the step that I show you to find the derivative of f of 1. The answer key gonna be f derivative of 1 will be equal to 4, negative 4, I mean. So you can try that. Go ahead. Okay, so now let's pull down to the fact. An alternative way to compute the derivative f derivative a, sometimes easier to use, is let b equal to a plus h, then h equal to b minus a. Yeah, subtract a from both inside, right? You can see h equal to b minus a. Then we can actually write, we can write that slope of the secant line through PQ equal to f of b minus f of a, which is like y2 minus y1, like the formula, previous formula in the algebra class, right? And then x2 minus x1 over here. See that? Now, because of the formula here, I can change b minus a become h, right? And b, from b here, I can change it to become a plus h. Now that's what we should do. And then taking b go to a, go closer. Oops, sorry. Closer and closer to a, then it's actually the same as taking h go closer and closer to 0. So in order to find the derivative of f of a, you can either go by the formula as limits of fb minus fa over b minus a for b approach to a, or you can go by the form that we just use on the by the form of star, which you use on the first page over here, right? So yeah, so now you have two formula for you to use. Let's try to do example 30 with the form, with the equation that the second the 2 star above, and then and see what happened, right? Okay, so remember that we did this problem already, and we got the derivative of f3 going to be equal to 5. Let's see what happened if we use this formula. Okay, so I have limits of fb minus fa over b minus a for b go to a. Okay, but what is a now become? It is 3, right? So I can rewrite as limits of b go to 3, and then all f of b minus f of 3, right? Remember that we have f3 already. And then b minus 3, right? And then actually I can have a side work over here. Side. From above, I know that f of 3 equal to let me make sure 6, right? 6. Okay. So f of 3 equals 6. And then f of b will be equal to b squared minus b, right? So I can just substitute it. I don't even need this much. Okay, so limit of b squared minus b and then minus 6. Excuse me. Divided by b minus 3. from B go to 3. Okay. So in this case, you can you actually can have limits of B go to 3 from B squared minus B minus 6 over B minus 3. And you can see that in the top now, it is a quadratic formula. And you can remember that you if you want to think about the direct substitute, I don't think that you can do direct substitute now, because if you do it, then the bottom becomes 0. So you have to think about, can you factor the top and bottom, and then see if you can cancel something. So in this case, I expect that I will factor the top, and then I will get a common factor as B minus 3. So then later on, I can cancel this B minus 3. Okay. So let me, so in order to factor it, you can apply the AC method. Okay. Or if you remember the special form for the like a square binomial, but if you cannot remember it, so just gonna do AC method for this special case. Remember that A in here equal to 1, B in here equal to -1, and C in here equal to -6. For the special case that A equal to 1, that's going to be easier for you guys. So A times C going to be -6, and B equal to -1. Then two numbers that multiply each other equal to -6, and addition equal to -1. What is that going to be? I'm going to say -3 and 2. Yeah. So, yep. So you're gonna have, let me write it down here. Limit of B go to 3. Yep. For the function, the top one I want to be B minus 3 and B plus 2, right? You must the two number here. Give me B minus 3 and B plus 2 for the factor at the top. Divide by maybe, so that's gonna become a sidewalk. And then top bottom will be B minus 3, right? So now you can see that, oh, you have a common factor between top bottom with B minus 3. And then you can have only limits of B plus 2 with B go to 3. And then direct substitute time, you have 3 plus 2 will equal to 5. This should be exactly the answer from above work. Okay. So let's move to the exercise to try over here. And you can go ahead and try on this. Make sure that you are using the formula that I have provide the second one over here for this exercise. And the answer should be written in the such of the way that you did the square root of the square root. Okay. So so yeah, the answer should be answer key should be 1 over 2 square root 5. Okay, so let's try to figure out how to do it later. Okay, so in class I'm gonna show you this if you don't know how to do it. Okay, but yep, let's try the best. Okay, so now let's move to the tangent line. Someone still want to say, oh, what is tangent line? Okay, definition. The tangent line to the y equals to mx at point P over here, right? Is a unique line, only one line. So you have only one line. Through, it's with through. Okay, through. P whose slope is equal to f derivative a, right? And which is a derivative of f at a. And the tangent line has equation as yx equal to f derivative of a times x minus a plus fa. This yeah, this is the function of this tangent line. Okay, like a slope and you this one actually like using the part slope form. Okay, I saw that. So like here the slope x minus x1 plus y1, and here's y. Right? You can know that part slope form as y minus y1 equal to m times x minus x1. You see that from that I can derive it to the next one over here, right? Okay, so note that the tangent line has following two properties. If we substitute x equal to a into the equation of the tangent line, we get ya equal to f of a. And line goes through the point p equal to a comma f of a, right? And the slope of the tangent line is f dv of a. Okay, so that's just what you need to know. Now let's do the example 31. Maybe I keep it like this so you can find the equation of the tangent line to the function f of x equal to x squared minus x at the point p equals to 3, 6. So at first you always have to compute like first step, find the slope, right? Find the slope of the tangent line, tangent line. At point P 3, 6, right? So that's gonna give, that's actually is I'm gonna write slope equal to f derivative of 3, right? Which is fa over there, right? Yep. Instead of writing m, I'm gonna just write slope because maybe you want to make sure it is slope. Okay. And it's equal to what? You need to use oh, you know what? We did found it, right? This is exactly the function we learned. We did above. That's equal to 5. Okay. And now we're gonna just apply. We apply, right? So we apply by using the equation of tangent line form we have, right? Y of x equal to f derivative of 3 times x minus 3 plus f of 3. You should know that f of 3 in here equal to 6, right? Which is this guy? 6, right? So you can now substitute in. You have y of x equal to 5 times x minus 3 plus 6. And that should be the equation of the tangent line. If you want to make it become, you can actually stop here. You can stop here. Because this actually show me the, sorry. Because this actually show me the tangent line equation already. However, if you want to make it look nicer, right? Look exactly like a slope-intercept form, then you can go ahead and go and simplify it. So you have y x equal to 5x minus 15 plus 6, right? You do distribution. And then you have y of x will be equal to 5x and then minus 9. And this should be a nicer form at the equation of tangent line in slope intercept form. So this is a nicer way to show the reader like me. Okay, so so you can go ahead and work on exercise try 25. Yep, and the answer should be is y equal to 5x minus 22. Okay. Okay, now what is application of this? Why we have to learn this, right? We can apply it to find the instantaneous velocity, or sometimes somewhere say like instantaneous rate of change. Let's call it instantaneous velocity. Let fx represent the position of particle moving on a straight line at time t. Then the average velocity on on the interval from a to b is the same as the slope of the secant line. Okay, this is what we learned from I think from the first day, from the first session. And the second one is called instantaneous rate of velocity of the particle at time t equals a is f dv of a, and we can use both of these two forms to find this instantaneous velocity. Okay, so let's do example 32. If ball is thrown in the air with velocity is 3 feet per second, its height in feet is given by st equal to 3t equal minus 16t squared. Okay, so use this to find. Okay, so A, the average velocity of the ball between t equal to 1 and t equal to 2 seconds. So you can have solution. And the B is looking for the instantaneous rate of change. So the velocity of the ball at t equal to 1. So the solution is first is A, the average velocity. Average velocity on 1, 2. Right. Going to be equal to f of 2 minus f of 1 over 2 minus 1. Right? So now you can have, what's L2? Actually, I should change it to, because in here we are talking about S. So I'm going to use S instead of F. Right? So I don't want people gonna, you know what? I'm gonna change it to become look like an F better, right? So you guys, instead of using S, because sometimes S look like a number 5. So I don't want you to misunderstand that. So this is F2 minus F1, and then I can make it equal to 3 times 2 minus 16 times 2 square, right? This is for the F2, and minus for 3 times 1 minus 16 times 1 square. That divided by 2 minus 1 is 1. And then use a calculator, you can easily find that that's going to be equal to negative 58 minus for negative 13. And that's going to equal to negative 45 seconds. So the feet per second. Negative 45 feet per second. So so it mean what? It mean the ball is towing is give me 1 second, let me see. With the average velocity at negative 45 feet per second. Okay, so let's move to B. It talk about the instant velocity. Let me use the instantaneous velocity will be at t equal to 1. Then you can use the form as f dv of 1 equal to the limit. So if you like, yeah, either way you can go. You can go by the first form or the second form. Let me go by the first form with the h 0, right? So f of a plus h. Now a is 1, right? 1 plus h. Minus for f of a is f1 divided by h. So I can do a side work first to make sure I don't mess up with that. So I have f of t equal to 3t minus 16t squared. So f of 1 plus h, or maybe I should start with f1 first. going to be equal to 3 times 1 minus 16 times 1. We give you negative 13. And f of 1 plus h will be equal to 3 times 1 plus h minus 16 times 1 plus s squared. Okay. So now you will have to do distribution. So equal to 3 plus 3h minus 16 times, for 1 plus h square over here, you can apply the square of binomial, or you can just do FOIL. So 1 square plus 2 times 1 times h, which is 2h plus h square. And then one more time distribution, I have 3 plus 3h. Okay, minus 16 get in. So minus 16 times 1 is minus 16. Minus 16 times 2h is going to be minus 32h. Minus 16 times h squared going to be minus 16h squared. Okay, so now you can simplify like combine a term. So you have 3, let me start with the h first. So negative 16h squared. And then h gonna be minus 29. And then minus 13. Okay, yep. 29h, I forgot. All right. So, okay. So now I'm gonna have f the derivative of 1 will be negative, let me pay parentheses, 16 s squared minus 29h minus 13, and minus for f of 1 gonna be negative 13, right? Don't forget the parentheses so you don't mess up with the negative positive. And oh, I forgot the limits. Go back a little bit. Limit of h go to 0 for h. Okay, so now let's simplify it. Limits of h go to 0 for negative 16h squared minus 29h minus 13 plus 13. Okay, and then you have h at the bottom. So you can now cancel the negative 13 and 13 over here, and you can factor h out on top. So you're gonna have limits of h go to 0 for h, factor out, and then negative 16h minus 29. I just need to factor out on the h because why? Because I want to cancel the h at the bottom. Someone gonna factor the negative 1 also, but I say no, you don't have to do that. Because you just want to cancel the h at the bottom here with the common factor. So now you have just limit of h go to 0 for negative 16h minus 29. And you can do direct substitute now. So that's going to give you 16 times 0 minus 29. That gives you negative 29 as the answer. So it should be negative 29 feet per second. Okay. That is it. Okay, so now let's come back here. And it is like a summarize all the things that we have learned about derivative and average and tangent and average velocity, instantaneous velocity, and you have some exercise to try it out here. Okay, let's see. So in this exercise 26, let me give you some hint. For A, we are looking for the f derivative of 4, and you can use either formula for 1 star or just 2 star. Actually, usually you're going to use the first star. Usually you're going to use that. So someone, you guys can try to use the second one and compare with the first, and let's see what happens. So for the f derivative of 4, if you're using the first one, it's going to be like a limit of f of h plus a is 4, right? And minus for the f of 4 divided by h for h go to 0. Okay, so you can keep going from here to get f derivative of 4 equal to 5 as the answer. Okay, go ahead and try it. Make sure later on you have to have some way to eliminate the h at the bottom here. Okay. For B, it says suppose g of x is function satisfies g1 equal to 10, g derivative 1 equal to 12. Find the equation of the tangent line to g at the point 1, 10. Okay, so remember that the equation of the tangent line is f let me eat y of x will be equal to g derivative of g derivative of a, which is 1 in here, multiplied by x minus 1 minus a is 1 in here, right? And then actually, you know what, I'm just gonna write out exactly the formula so you can apply it later. G of a and a here, and then g of a, and keep in mind that we have a equal to 1 and g of a equal to 10 because of this point. Okay, so that's going to be one thing that you need to apply in here. And then finally try to figure out like a form, a nice form as the slope-intercept form for the equation. So that is good practice. And C, this application, if a ball is thrown in the air with the foot velocity is 4 feet per second, right? With this function here, we're gonna find average velocity. Let me write AV, okay, and it's IV, okay. So A for problem, I have AV will be equal to F of 2 minus F of 1 over 2 minus 1. Okay, so then you will have answer as here, negative 44 feet per second. Try it by yourself and see what happens, right? And then the second one is IV, gonna be the limits of f of f t equals 1, right? So I say 1 plus h minus f of 1 divided by h for h go to 0. And just go ahead and try to do this amendment to get the answer as negative 28 feet over second. Okay, so we're gonna stop this section here, and I'm gonna see you in the next section. Okay.